Thank you for attending our Indiana-Michigan Power webinar, Uncover Energy Savings, Benchmarking, Auditing, and Troubleshooting. My name is Chris Guthrie, and I am the host of today's webinar. We will be sending everyone a follow-up email within the next couple of days that will include a PDF of the PowerPoint presentation materials and the playback link to the recording of today's webinar. Because of the large number of attendees, we will only be accepting written questions from you today. Please submit any questions by typing them in the chat or Q&A windows on your screen. We will take some time at the end of the presentation to answer your questions, or we will follow up with you separately after the webinar has concluded. To expand the presentation to full screen, click on the diagonal arrow icon on the top right corner of the slide. We will be conducting polls during the presentation. A polling window will appear on the bottom right of your screen, and you will be asked to answer one or more multiple choice questions. We really appreciate your participation in our polls. I'm opening our first poll now. Please be aware that you are not the only participant today. The names of other attendees are not being shown to you for reasons of privacy. Now let me introduce you to today's presenters. Mike Carter is a senior energy engineer and has a BS in engineering and an MBA degree from The Ohio State University. He has worked with various EPRI centers supporting electro-technology applications and spent 10 years conducting due diligence for the technology commercialization. Mike is a certified energy manager from the Association of Energy Engineers. He also writes articles for the newsletter, answers Ask an Expert inquiries, and develops webinars on energy topics. Also joining us today are subject matter experts Jason Whitman and Bob Barnacle. And with that, I'm going to turn things over to Mike to start the presentation off for us today.
Well, thank you, Chris, and welcome everyone to our webinar today on uncovering energy savings opportunities. It's said that what you inspect, you can expect. And I think that's a good phrase to encompass what we're talking about today. And one of the best ways to inspect your facility and look for these energy-saving opportunities is through a process called benchmarking. It's really a top tool used by leadership today to support decision-making, and more building owners have integrated it into their energy management strategies, and really more jurisdictions now require benchmarking of buildings. For instance, in the state of Michigan, it's required energy benchmarking of government buildings using a portfolio manager ever since about 2005. And it's also proven that benchmarking typically results in steady improvement in energy efficiency over time. The EPA did an analysis of about 35,000 benchmark buildings and found that on average energy use declined by about 7% over a 3-year period. Now ideally, it would be nice to be able to sub-meter all the equipment, energy end-use equipment, the lighting and HVAC and compressors or whatever we have in our building, and to know exactly how much energy they're consuming and be able to benchmark that. But that's very expensive from a capital expenditure standpoint, very time-consuming. And so, but there are other ways to get close enough, and that's what we're going to talk about today. We're going to show you some tips and tricks on how to estimate not only your overall energy consumption for benchmarking, but also some of the sub-segments as well. And so we're going to look at a number of high energy users with distinct usage patterns based on their unique business requirements, as you can see here. And we're going to review each of these segments in detail and then talk about how we can figure out, well, what's our energy performance overall and also in things like HVAC lighting, et cetera. And if you don't see your segment here, it's going to be, I'm sure there's one that's going to be very much like these, and so you can slightly extrapolate, I'm sure, for that. And then we're going to also at the end leave you with a very practical checklist of things to look for to uncover energy savings opportunities in your facility. You can put these on a clipboard, walk around your facility, check off the number of things we have in these areas. So, but with that, let's go ahead and start and talk about one of the most ubiquitous areas of energy consumption, that is with commercial buildings. And one of the ways you can, one of the benchmarking sources you can use out there is the Commercial Building Buildings Energy Consumption Survey, we call it CBEX, and it's been updated recently. Now, you might not be impressed by how early it's been updated, but the old data was 2002. Now we're up to 2012, and there's distinct patterns of change over those 10 years. There's generally less electricity consumption per square foot, and the mix has changed. The lighting has dropped quite a bit as a percentage share of total electricity consumption. But I've put together a list of business segments here, the average kilowatt hour per square foot consumption, and the median, and the 25th percentile, where you'll be performing better than 75% of your peers in these areas. You can use these numbers, and I'll show you how here in a second, to benchmark your facility's performance. We also included gas intensity. Most of you have gas as well. I thought that might be helpful. Did the same thing, average, median, 25th percentile, in cubic feet per square foot of facility space. So again, almost all of us have office space, even if you're a manufacturer. So we're going to start with that area and take a look at, well, where is energy consumption happening in office environments? Well, here's the CBEX data for offices. First thing we want to look at is, hey, what's the overall energy benchmark here? But just short of 16 kilowatt hours per square foot total, and that's an average. And so being in the Midwest, we'll kind of be in that average, even though it will be probably more for southern states with higher HVAC, a little less for more northern states. But that's a pretty good number. And then the second thing you want to look at is, well, where is it being consumed? And so here's a breakout here in this pie chart. Ventilation's a fourth of it. Office equipment and other actually would be, both of them, pretty much plug loads is a big part of that as well. And so if you look at ventilation and cooling, which are the two blue areas here, you can see that that consumes about half of the office space. Now, it used to be lighting was, right now it's 16%. It used to be 30–40%, but, and this is 2012 data, so it really reflects just the upgrade from T12s to THT5s. And of course, today, that lighting will probably be even a less percentage with LED lighting being implemented. So HVAC, plug loads are two big areas you probably want to look at opportunities for. So how do you use this data? Well, just take your electric bill, take an annual number. Let's say it's 1.6 million kilowatt hours of use. You have an 80,000 square foot facility. That gives you your 20 kilowatt hours per square foot. Compare it to that 15.9 kilowatt hours per square foot. And you can see that, well, gee, overall, possible improvement opportunities should be available there. And you can go to management with a hard number like this and justify continued use of resources and money to do so. If you wanted to see, well, which area is it the biggest opportunity? Is it HVAC, lighting, et cetera? Well, there's a couple things you can do, kind of a back of the napkin type analysis. And here's one. If you heat with natural gas, then your electricity usage is going to be pretty steady year-round for things like lighting and computers, et cetera. And the biggest difference will be in the HVAC, the air conditioning system. And if you plotted cooling load hours, total hours that your equipment is going to operate at full capacity, mathematically, it's going to operate more hours total, but it'll be at reduced capacity, but an equivalent full capacity load hours versus the time. You can see here that, of course, most of that occurs in the hot summer months, but at the winter months, January, February, December, hardly any. That might be a little bit. So you can say, well, I know that the biggest difference from a baseline is going to be attributed to HVAC for air conditioning. So what you can do is take your energy consumption. This is kilowatt hours, thousands of kilowatt hours. This is an example. So it'd be very low in January, February, very high in the summer months. Total of this case, 1,500,000 or 1.5 million kilowatt hours. And if you took, say, rule of thumb, 80% of your shoulder months here, where you shouldn't expect much air conditioning, use that as a baseline and then subtract the actual minus that baseline. This difference can be attributed to your air conditioning. And so now you can say, well, then on this basis, I consume about 750,000 kilowatt hours in my air conditioning system over 80,000 square foot, and that's about a 9.4 kilowatt hours per square foot. And if you saw on that pie chart, HVAC, cooling, and ventilation together were about 6.1 kilowatt hours per square foot per year. Oh, again, now you've just flagged, hey, it looks like maybe our HVAC system isn't efficient enough. Now, what if you heat all electric with HVAC? Heating's electric, cooling's electric. Well, if you look at, again, the load hours, both cooling load hours and heating load hours, you're going to see another couple shoulder months in the spring and in the fall where you have very little HVAC contribution to your energy bill, to your electric bill in this case. And so we can do the same thing, put our actual kilowatt hour consumption, look at those shoulder months again, take about 80% of that as the baseline, and now we can say that the difference is going to be both the heating electric consumption as well as the cooling electric consumption together over 80,000 square foot gives us a number of 12.3 kilowatt hours per square foot per year. And again, if you go on the chart and you convert gas heating to electric, you're going to have about 12.3 kilowatt hours per square foot versus that's about what you got here. So you can say, well, we're pretty average. Maybe we can do better, but at least that isn't a huge problem in our facility. So just a couple ways to take your electric bill and do a little bit of math and figure out, is our HVAC system a big problem or not? The other thing you could do is use nameplate capacity on your equipment. If you know how many tons of cooling you have, and you know the efficiency either in energy efficiency ratio or your coefficient of performance, COP, you can convert that to something we call full load value or kilowatts per ton, which lets us do some simple math and calculate the estimated energy consumption of our HVAC. For instance, annual cooling load hours are shown here for St. Joseph and Muncie. If you have a rooftop equipment, your typical efficiency might be about 1.3 kilowatts per ton, chiller 0.8 kilowatts per ton for not very efficient units, older equipment. And then you can just take the loads per ton times that kilowatts per ton draw times the hours, because that'll give you tons times kilowatt per ton is kilowatts times hours is kilowatt hours. You can estimate, well, over a cooling season, I might consume 315,000 kilowatt hours for this 300-ton total of rooftop units, or if it was a chiller, 194,000 kilowatt hours. Take that divided by whatever your square footage is. We just happen to use 33,000 here. 9.7 kilowatt hours per square foot. Again, we go back to our benchmark, 6.1. You can see that you're pretty inefficient compared to average in terms of benchmarking. That's another way you can do that. And then, of course, the question is, well, how about what's the payback of upgrading, and particularly upgrading from a good efficiency to maybe best available efficiency? And again, using that kilowatt per ton number and assuming some energy savings, let's say 10 to 20%, you might have a rooftop unit that's at 9-year. That can be converted with a formula to 1.3 kilowatts per ton, about 11-year to 1.1, and you can calculate your HVAC consumption using just, again, tons times the efficiency times the hours, gives you the kilowatt hours for the good unit versus the very best unit, or at least high efficiency unit, and you calculate the differences as your annual energy savings from paying a little bit more for your more efficient equipment. Now that's energy savings. Now you might also have a demand savings that could be applied as well. We can go back to that kilowatt per ton number, subtract the 2 out. So you're going to say, well, for every ton of capacity, I'm going to reduce my peak demand by 0.2 kilowatts. And I already have this energy savings, let's say at 10 cents a kilowatt hour, the 48,480 kilowatt hours. Demand savings would be that 0.2 kilowatt per ton times 300 tons times the number. We'll use 8 as a ballpark average over, say, 8 months of the year. That would average out to be about $3,800. If you add those two together, you're going to have a total savings of about $8,700. Now, how how much you're going to pay for that. Well, let's say a 300-ton unit, you're going to estimate about $500 per ton. That's a $150,000 investment. Of course, if you're just looking to get a new unit that's more efficient, that savings compared to $150,000 investments, going to be a long payback. But if you think of it as, well, I probably have a 10% premium on that cost of $150,000 for $15,000 for the more efficient unit. I'm paying about I'm going to save $8,700 a year for that $15,000 extra payment, and now you're just looking at a pretty attractive about a 2-year payback. So that's how you can make that decision as well. If you have any questions about anything I'm covering here, just type those in the Q&A text box, and we can address those here at the end of our presentation today. And it doesn't have to be exactly about what we're talking today. This could be energy savings overall. So just type those in the Q&A text box. How about turning our attention to lighting? Now, we're talking about offices, but this example I gave and this one I'm about to give, that can be applied over all the other business segments as well. But in an office, we saw that from that CBEX data, you average about 2.7 kilowatt hours per square foot per year. How can you compare your own lighting to that? Well, you can do a walkthrough inventory, identify, well, how many lamps do I have, what kind of lamps are they, and you might even have T12s still in there and up in the ceiling versus T8s, and you can either measure those with a ruler, T12s 1.5 inch, T8s 1 inch, or you use your cell phone, just put it on photo mode, point it at the troffer, and you'll see a lot of striation with the T12s. 60 hertz, 60 cycles per hertz. You won't see hardly anything at the T8. You can kind of quickly determine, especially if it's behind some sort of a diffuser sheet, you can tell what that is pretty easily. And then use wattage tables like we show here, number of lamps, how long they are, to figure out what kind of wattage you might consume. That's for T12s, this is for T8s, and some LEDs. LEDs are going to actually be a little more efficient than this. And then determine how long do they actually turned on and what's your floor area. And then your energy consumption is going to just be the power in kilowatts. These are in watts. You have to divide by 1,000 times time. So if all that sounds confusing, well, let me give you an example. So let's say you have a space with 40 4-foot T12 fixtures, and they operate 12 hours a day, 5 days a week, which adds up to 3,120 hours annually. And the space has about 30,500 square feet. So if you take your 40 lamps times the watts, divide by 1,000 to get kilowatts, times the hours, that's going to consume about 18,000 kilowatt hours per year. Your electric intensity then is that 18,000 kilowatt hours divided by your square footage, about 5 kilowatt hours per square foot. Our benchmark was about 2.7, so you're pretty very high over that. If you had T8s, you'd probably be about that, a little above that, maybe 3.5. If you have LEDs, you can get it down about 2 kilowatt hours per square foot, which is a lot better than average, for instance. In terms of, well, how much savings can I get from using occupancy sensors or bi-level switching or dimmers or photocells, et cetera? Well, in terms of occupancy sensors, you can use tables like this that show the energy savings potential for different areas. It's going to be the highest for low foot traffic areas like meeting rooms, conference rooms, highest savings. Not so much for like offices, and particularly in open spaces where people are always tripping, the occupancy sensor lights are on all the time. But let's say you have a meeting room with 6 4-lamp, 34 T12 fixtures. From the table, we know that how many watts that consumes, times the hours, times it's a meeting room. So we're going to estimate about 50% savings. So we'll take half of that. Turns out to be 1,350 kilowatt hours a year. At 10 cents a kilowatt hour, that'd be about $135. So if you had to spend, I don't know, $270 on the occupancy sensor, the wiring, some labor for that, well, you have, again, about a 2-year payback. Now, you can use bi-level switching. A lot of the codes, energy codes, are requiring that now, where it can go from, say, 100% on to 50% on or even 30% on. You can use dimmers, either, again, That's going to be continuous, not the step changes here, but it'll be more continuous. And you can use, of course, daylight sensors as well. Get that free daylight when there's enough light and turn off the artificial lights for savings. Another area in offices especially are the presence of personal appliances. What do we mean by that? Well, you could go over to a cubicle and find somebody has a space heater, a mini fridge, a microwave, a portable fan, a coffee pot warmer, and who knows what else. I know one of our colleagues here that she uses a heated mouse in the wintertime to keep her hands warm. So there's a lot of energy consumption happening for personal appliances. And that adds up. If you look at the power draw for each of these, the kind of estimated hours they might be operating and get the annual energy kilowatt hours consumption, add it all up, you're talking about 1,360 kilowatt hours a year per office cubicle. And 10 cents a kilowatt hour, that's about $135. That's going to add up very quickly. You have 100, 200 employees. So what do you do? Well, there's a couple things you can do. This is just what other people have done in offices. You could require a formal request to use those things, or you could even charge for them in some manner. So it's pretty radical, but sometimes you have to take some serious steps if you have that much plug load consumption happening in your facility. Office equipment consumes a lot of energy. Be aware that typically modern office equipment has 3 modes of operation, whether it's a desktop computer, laptop, printer, copier. We'll have a typical operating power, the maximum power when it's turning out copies or processing Excel spreadsheets. Then when it sits for a while, it'll go into idle mode, and that'll be a pretty good reduction. You can see what kind of reduction here. It's a larger reduction. And a lot of systems today have even a lower energy or power draw called sleep mode. And so for desktop computer, you might be running 100 watts full bore and 6 watts in sleep mode. And so what we did was we calculated annual energy costs for both a sleep mode use in 2 cases and no sleep mode at all. The 2 cases were, well, somebody at least turns off their computer and printers and things at night and over the weekends, but it has sleep mode. Or just leave it running all the time in sleep mode. Or leave it running all the time and don't have sleep mode. And we made the assumptions down here what percentage of time that would be, and 10 cents a kilowatt hour to make the math easy as a ballpark. And so we can see here the difference between the desktop computer just running all the time without sleep mode, and then running with sleep mode and being turned off during the nights and weekends. It's about $40 per desktop computer, for instance. Let me show you a couple other examples of that. So here's a desktop computer with a CRT monitor and no sleep mode versus sleep mode, running at 24/7. And you see the difference here, just using some simple assumptions of 10 cents a kilowatt hour. About $70 per year per computer can be achieved just by using sleep mode. And there's a number of pieces of software out there. If it's not built into your computer's operating system, Rudium has a surveyor software. Living Life Green has what's called their CarbonWise system, and even AKS-Labs has what's called Watch Over Energy product out there that can monitor and control quite a few computers in this regard and achieve that kind of savings. If you just upgraded from CRTs to LCDs, what would that be worth? Well, if you have sleep mode, not a lot, but if you're operating without sleep mode, you can save about $20 a year, for instance. So, and that's how you estimate that using that table. So another poll question here, which of the following have you implemented at your facility? So here's 4 different things. Some are energy end use things like LED lighting, lighting control. Some are process things, energy management activities. So let us know that. We'll take a look at what everyone has to say here in just a few minutes and see where we're all at today. So that was an office environment, but everything I shared there you can apply and do the same thing to a retail outlet, and in fact, to all the other business segments that I'm covering today. So I'm going to just spend a little bit of time just showing you what the breakdown is for these areas, and share another tip here if it's unique to that particular one. But if you look at retail consumption, again, what's the bottom line? About the same as an office, but the breakout is quite different. In this case, lighting is number 1, refrigeration is number 2, and then ventilation and cooling, which would be here. So it's spread out quite a bit, but lighting's still a good opportunity to look at, and HVAC is still a decent opportunity as well if you look at those numbers. And you can see that the lighting is a little even more higher in terms of a kilowatt hour per square foot area compared to offices. I think it was about 2.7, I think we said it was. So that's another thing you want to look for, is what's the actual magnitude, even though it might be a small percentage. When you jump to hospitals, boy, the story changes quite a bit. Now you're looking at twice the electricity consumption kilowatt hours per square foot total. You're going back to cooling and ventilation here and here being, quite a large chunk, about 40% of the total. Lighting is a relatively small, and then you have a lot of plug loads, both other and office equipment. So you have, of course, medical equipment and monitors and pumps and MRI machines and now that kind of a thing. So there's a lot of opportunity overall in hospitals and healthcare area. Going to hotels and motels, lodging, again, close to retail and offices. Again, plug loads, other, and office equipment's pretty high together. Ventilation and cooling are pretty high as well. So you have a great opportunity for HVAC upgrades and plug load reduction in the lodging area.
And Mike, we have the results of our poll back if you would like to share those.
Oh, thanks, Chris. So which of the following have you implemented at your facility? And so people who answered this, mainly LED lighting, lighting controls, not so much in terms of the energy management practices we're talking about today, energy audit, energy benchmarking. So hopefully this will be of value to you then. Maybe something else you can try at your facility. Let's take a look at grocery convenience stores. Maybe this might surprise you, maybe not, but it's even higher than hospitals today, and almost 50 kilowatt hours per square foot total. And the biggest chunk, if you look at the breakdown, very obvious here, is refrigeration. Lighting's not a big percentage, but it's pretty high in terms of kilowatt hours per square foot, much higher than, 50% higher than offices. And so refrigeration is a big one. Lighting would be another area to look at, particularly because the total hours that are spent with the lighting on in a lot of times 24/7 grocery and convenience store operation. Grocery and convenience stores, of course, in the refrigeration area, it's such a huge percentage. How can you estimate what those coolers and freezers are consuming in energy? A couple ways to do that. Again, rather than expensive, time-consuming sub-metering, you can go to some of the cooler freezer manufacturers. They have on their website an estimate of what their consumption is for different size of their coolers and freezers. And so, as you get bigger and bigger, of course, the kilowatt hours, in this case, kilowatt hours consumption per month are shown here. And if you look at freezers, wow, it's, about 3 times higher than the same size cooler. That makes sense. You're at a much lower temperature. It's going to take a lot more energy to get there. And the rule of thumb is about 3 times as much for the same size. So that's one way you can do that, to kind of see what your energy consumption is. Another way is a more brute force method, and that's looking at your nameplate data on your compressors, fans, both condenser, evaporator fans, and you know what the voltage is typically, and we're going to assume this is the case, in this example is a single-phase 240-volt operation, and we know what the 3 compressors running at 15 amps, 45 amps total all the amperage up. We use a simple formula, amps times volts times power factor. Just use 0.8 as a reasonable ballpark number. Gives you, divided by 1,000 gives you a kilowatts, times your hours is kilowatt hours. So in this case, this unit would be about 6910 kilowatt hours per month using that nameplate data. If you had a 3-phase system, your voltage is going to be different. Maybe it's 480 volts or whatever, and then your amp reading would have to be multiplied by the square root of 3 or 1.73, I think it is, to do this calculation using 3-phase operation. But this is an example, for what I call the brute force method. You can back of the napkin estimate what that's consuming in that manner as well. Best energy saving options. This is older data, but it's still applicable today in terms of what are the cooler for refrigerator and freezer technologies that you can use to reduce energy consumption, and for refrigeration, more efficient compressors, anti-sweat methods that don't use electricity or use condensate sensors that only operate when it's needed. You use electrically commutated motors for fans and maybe even compressors. Those are basically variable speed DC brushless motors that are built-in variable frequency drive operation, saves a tremendous amount of energy. You see that percentage of energy savings that we're talking about here for those. And if you look at freezers, many of the same similar things, even typically higher levels of savings as well. So there's just some good ideas, things you can look into if you're looking at reducing your refrigeration energy consumption. Well, that brings us to restaurants. And again, very high electricity intensity on an annual basis, about 45 kilowatt hours per square foot. Refrigeration is a big part of it, not as big as we just saw, but percentage-wise, but still really high in terms of kilowatt hours per square foot. Cooking is another, of course, area, kitchen area. Cooling and ventilation, not as big on a relative scale, and so they only represent about 20% of end-use intensity. So we're still looking at refrigeration opportunities, and now we're looking at cooking opportunities. And we'll cover those in our audit at the end here that we're going to show you. Manufacturing, I went back to the data source and used manufacturing energy consumption survey data. And I just discovered actually yesterday that 2014 data is out. It was 2010. That they didn't have 2010 enclosed areas, and so I had to take the 2014 electricity consumption divided by the square footage of floor space in some of these areas. 2010, I think that's a pretty reasonable ballpark number they'll give me. At least I'll use the latest 2014 data. And so here's the consumption. You see it's quite a bit bigger than the commercial area. And again, petroleum refining, it's astronomical. You got to take this with a little bit of grain of salt. It's kind of hard to say, well, what is the floor space that we should be covering here? I mean, there's lights outside on catwalks and other areas. There's a lot of cooling going on in the process area, and so, but it's again very high. Probably a little more rigorous are these numbers, like newsprint mills, aluminum, copper smelting, making fertilizers, wet corn milling, paper mills. You can see maybe one of these is your area. You get down to beverage and printing, it's a lot lower, more like some of the commercial areas as well, fabricated metal products, et cetera. So you can take your, again, electric bill if you're a manufacturer, divide it by your square footage, and then compare yourself to these areas. And if you want to look at the data a little closer, here's where that source data is. You can Google that and find that pretty easily. One other thing here before I leave, biggest, when you look at the pie charts on these, the biggest area is motors. 40 to 50% of the total electricity consumption in a manufacturer's facility is typically motor energy consumption. One of the motors that are used is used to compress air. And we're going to have a whole webinar on this coming up November 8th. We'll get into this in great detail, but just overall, just recognize compressed air, well, it's considered the most expensive utility, and it's not really a utility, but it's so expensive that people think of it as like the 5th utility besides, you know, electric, gas, et cetera. If you do some math and assume that, well, it takes about 1 horsepower to produce 4 cubic feet per minute, 4 CFM of air, then you can noodle on the paper and say, well, it would take a 1 horsepower air motor cost me about $13.58 to operate it a year versus a 1 horsepower electric motor about $194. So you can see just how expensive it is to operate equipment using compressed air. Now, there's other advantages for compressed air in terms of equipment, grinders and cutters, that kind of a thing. And so it's not just an energy or electric cost decision, but it is very expensive. It can easily average $100 per CFM per year. And typically, your demand components, half of it's that's created is actually consumed for useful work. A fourth of it often gets dissipated away in the atmosphere and leaks. A lot of times you're using wrong applications, and excessive pressure can waste energy as well. Again, show up at our November 8th webinar. We'll go into this in much more detail. With motors, you can save through using variable frequency drive motors. And here's a plot of flow rates versus input power for an application in which when you want to reduce flow rate, you can either do that through mechanical dampening, like an outlet damper, inlet guide vane, disc throttle, variable pitch, axial fan, whatever. And here's a plot showing, hey, if we forced through mechanical dampening a flow reduction of air or water, those are the best opportunities for VFDs. Using an outlet damper at 50%, we're still going to operate at about 75 to 80% of power. That's not a very good deal. If we use an inlet guide vane, let's say it's a fan application, at 50% flow rate, you're going to consume about 50%. You're thinking, well, that's pretty good. Maybe that's the best I can do. Well, if you use a VFD, you can reduce energy consumption at 50% flow rate rather than mechanical dampening by slowing the motor. Now you're at about 16, 18%. So you can save a tremendous amount using VFDs. Let me give you an example. Let's say you have a 50 horsepower motor. It's about 41.4 kilowatts, assuming like 85, 90% efficiency. 50% horsepower output requires 41.4 kilowatts input of electric power. And it's operating 16 hours a day. And so that's 662 kilowatt hours a day. But let's say I don't need it to operate actually at full load 16 hours. I only need it to operate at full load, let's say a couple hours, and I can run it at reduced loads for many more hours than that total more than 16 hours. So I put a table together here and said, well, let's run it at 100%, 75, 2/3, and half speed. And I calculated, well, what would be the kilowatt hour draw at each of those using a VFD? And you can see here at 100% load, actually it's a little higher than without a VFD because it takes energy to operate a VFD. But when you get into 75% load, you have a table here. Here's the speeds. 75% load would be about here, so it would be about 42% power draw at 75% speed, or 30% at 67%. And then I just calculated that kilowatt draw. I assume that you'd be running, 2 hours at full operating speed, 8 hours 3/4, 8 hours 2/3, 5 hours a half, so 23 hours. So you're thinking, well, I'm running the motor about 7 hours longer than I used to. What's my energy consumption? Wow, it's half, even though I'm running longer hours. And that's the magic or beauty of using a VFD for energy savings. You can look at this here in detail after the webinar's over. You get a copy of this, and you can consider that. Just going to very quickly run through this audit checklist. Again, if you have any questions about what we shared today, type those in the Q&A text box, and we'll answer those questions. But for all business segments, building envelope, you can do a lot of different things. You know, one of the big ones, replace cracked or missing window and door caulking. So like I said, take this, walk around, look around your facility, see if you've done these things. If you look at HVAC operation, no matter what kind of business you are, you can do winter temperature setbacks, maybe 50 degrees overnight. You got to be concerned about not getting too cold for pipes freezing, et cetera. In the summertime, maybe 84 degrees set forward. Again, not too high. You're going to be worried about mold happening, et cetera, and a number of other opportunities that are listed here. If you look at HVAC maintenance, because your maintenance can affect your energy consumption as well, you know, hey, just see, are my registers covered up with stuff? And, you know, in a university environment and dorms is very common. Maybe even hospitals, other places that can happen. There's a number of other things here we show you. For lighting, again, this is pretty much all commercial building segments. Occupancy or vacancy sensors for low foot traffic areas. Always, you know, going to save, again, if they're low foot traffic areas where the lighting would tend to not be anybody there for long periods of time. You can upgrade some of your high bay probe start metal halides with fluorescent or LED. LED is very competitive these days. Number of other things. You see the word LED here quite a lot. You can pretty much replace almost any lighting with LED and save and get a good payback these days. In terms of lighting maintenance, taking care of that lighting, and make sure that they're clean for maximum illumination. If you're in a dirty work environment, you can really reduce that light output quite a bit. And some other things here. Hot water, thermostats, temperatures, set it down no less than 120. You're going to be concerned about Legionella. If you get too much cooler than that, it should be okay at that temperature. Water leaks are fixed, etc. If you look at refrigeration operation, and make sure all the air doors, strip curtains are used on freezer doors. Freezer doors, you know, use floating head pressure controls when the outside temperature is pretty cold in the fall and in the wintertime. In terms of maintenance type of things, you know, worn and leaky door seals are replaced. Automatic door closers are operating the way they should, so there's not a big air infiltration into the cooler or freezer. Kitchen operations, you know, plug loads are growing and growing in kitchen operations. Just look to see what's plugged in the wall and see if it needs to be unplugged for most of the day. And what else we have here? You know, using sensors to turn down heat. If you have conveyor systems, et cetera, it could be running all the time. The heat's being on full blast, and there's not even any food on the system. In terms of kitchen ventilation, you know, use temperature or optical sensors with your exhaust hoods. We call that demand-controlled ventilation for that, so that you don't exhaust indoor air through the exhaust hoods in the kitchen more than you have to. In terms of manufacturing customers, we said motor operation is the big one. Use VFDs for variable torque loads when you only need to operate at full load a little part of the time. If you just need to operate at a lower level all the time, don't use a VFD. Just use a gear reducer or just replace the motor with a smaller motor. It's a better investment than a VFD. VFDs aren't cheap, but they save a tremendous amount for the right application. The right application says, I still need to run at full rated capacity a little bit of the time, 10 or 15%, but most of the time I can run it a lot less, even if I have to run it longer, as we saw in that example. And then pump operation, use, again, VFD for variable load pump applications. If you just, again, need to run, if your pump's over capacity, just use a smaller impeller. It's called impeller trimming for constant loads, and you're going to save quite a bit that way. We'll throw this in here for free, boilers and steam systems. Steam trap leaks detected and repaired. There's a number of things you can use. Look here to check for those systems to save as well. And then process operations, remove power from unused transformers. A lot of times that meter will be spinning. Our customers are like, well, I have this empty warehouse. Well, it's because you have power to transformers on the primary side, but there's nothing going out on the secondary side. But it's still consuming energy just to create the magnetic fields in that transformer core. And so there's core losses, and it can be 700 watts, several hundred watts per transformer. It adds up. Use electro technologies, industrial heat pumps. If you want to heat up, use waste heat from a process and heat up another process up to 250 degrees high temperature, a difference of about 100 degrees, and you probably need at least 500,000 BTUs of waste heat source in order to justify this. Radio frequency microwave heating and drying can replace gas applications, again, below 750 final temperature. There's some thickness restrictions, but not too much. And then induction heating as well can replace some gas heating as well. Very efficient heating process there. And we mentioned compressed air operations. Hey, don't use it for bad applications like a moving product or cooling things. And then, system pressure reduction as well. Again, come to our November webinar and you'll hear a lot more about that. Last poll here, would you like someone from our utility to contact you about finding energy waste in your facility? And then how valuable has this webinar been to you today? And there's 5 choices there. So appreciate you filling that out. I'll just wait just a second while you jump on that. We really appreciate that feedback you give us. And let's take a look at a couple other things. The Indiana Michigan Power Energy Solutions Service has what's called tools you can use. And if you click on that from your email, you can see something called a Facility Assessment Wizard. That'll do a self-audit. It has a 5-step process. Tell us, what kind of business you are, a climate zone, what's your energy use of most interest. If you pick cooling, lighting, et cetera, then you're going to get additional questions, and then it will produce a customized report to give you tips on how to decrease your cooling, lighting, or whatever energy consumption. The second thing you can do is look at the commercial energy efficiency and industrial energy efficiency recommendations tools. You click on those, and you're going to get screens that look like this for industrial energy. For a fabricated metal product segment, if you pick that, and then you pick a process heating, it'll show you the breakout of that and give you tips on that. If you use a commercial energy efficiency tool, then you can say, I'm a restaurant. You can see the different segments it has, and I'm interested in reducing my cooking energy use. Here's a breakdown of how much that is, and here's, again, some tips. I just show a couple here. It's a long list of tips that you can implement. Other helpful resources in terms of the HVAC, here's the AHRI website. We're going to be going to the AHR Expo coming up in January, kind of look at the latest and greatest air conditioning, heating, refrigeration technologies there. The DOE has a great commercial lighting solutions tool. You can do some what-if analysis there. What if I use timers on my lighting or occupancy sensors, et cetera. All kitchen operations, you can look up some good information from the Fisher-Nichols Food Service Technology Center. It has calculators for cooking, energy consumption. It has reports on specific pieces of cutting-edge kitchen equipment. And then, of course, for compressed air, the Compressed Air Challenge website is a great source of help and information on that. If you want to do need some help with energy auditing your facility, like to use some software that's out there, we have one. It's called the Small Business Energy Tool. It'll give you an energy report with recommendations, incentive information. There's one that's free. One you can pay for out there is this Energy Profile tool. It's a 30-day free trial, but it'll help you with your audits. NREL developed a SimuWatt system, and it's not clear if it's free or not. I don't think it is. It wasn't clear from the website, at least first glance, but you can put this on your tablet, and it'll help you with capital project decisions from energy standpoint. If you're an industrial facility, this DOE Industrial Facility Scorecard will give cost savings for different improvement opportunities. The DOE Plant Energy Profiler is another one good for manufacturers. It's kind of question and answer based, so you'll answer a bunch of questions about whatever it is that's consuming energy in your plant, and they'll give you some tips on that. And then finally, the Energy Star Portfolio Manager is a great tool to give you benchmarking data. It even does weather normalizing of that data as well. With that, I'm going to turn it over to Jason Whitman, who's going to talk a little bit more about 2017 energy efficiency programs at Indiana and Michigan Power.
Well, thank you, Mike. It was a great presentation. I appreciate you going through quite a wide array of topics, from HVAC to lighting to motors and compressed air and the tools and calculators. So thank you for giving that presentation. I trust all those who are listening found it helpful and will be something they can apply to your specific facility. I would be remiss if I didn't talk about how you can capture those energy savings and get a return via an incentive or rebate through Indiana Michigan Power. So listed here is a few of our programs. We have over 100+ measures which you can participate in and receive an incentive or a rebate for. And some of the things listed here, we've got a caps per site, and that is so that the majority of our customers in Michigan have an opportunity to participate and take advantage of our programs. And we have a prescriptive program, which is really designed kind of a one-for-one replacement for equipment, and we have a custom, which is more of our kind of our catch-all program. So if it's something's not listed in our prescriptive program, then we definitely want to be able to capture that as well. We also have a new construction, which is kind of a subset of our custom program. If you're looking to add a new facility or do a total renovation of an existing facility, we certainly would like to be able to assist you in capturing the energy savings there as well. And we don't want to leave out our small business customers as well. A big portion of our customer base is our small business customers. So we also have a program geared specifically for you, where we partner with a local trade ally who will come out and assist in doing a lighting audit and complete an application and getting you your incentive for energy projects that you do. And what I've listed here are 2017 programs, but we certainly will offer these through 2018 as well. So if you're interested in pursuing a project this year, or it may carry over to next year, just want you to be confident that we will have these programs in place for you as well. The process is pretty simple. Everything's done electronically. Our application is available at electricideas.com/work. You can go there and review our programs and download the application. And then all documentation is submitted electronically via email, and there's instructions listed on our website as well. My contact information is listed there. Again, this is Jason Whitman. I've got my office phone number and an email. Please feel free to reach out to me and ask questions, or if you'd like me to do an in-person visit, I would be certainly happy to do so. So once again, thank you for participating in today's webinar. I hope you found it very helpful. I'll turn it over to Chris, and she'll talk about our upcoming webinars. We encourage you to participate, and if there's others in your office or your facility you'd like to have be a part of that as well, we encourage them to sit in or log in and take advantage of them as well. So Chris, I'll turn it over to you, and you can kind of go over the upcoming webinars.
And Chris, I'd be happy to do that. We have 4 of them here in the near future. One is on the same day, 2 of them are the same day. In the morning, November 8th, we're going to be talking about compressed air systems, which I've talked about before, and we're going to look at where energy is consumed on the supply side of compressed air systems, the demand side, and we're going to talk about how to do a high-quality audit of your compressed air system. We're going to look at some of the problems you get in implementing variable frequency drives on compressed air systems. And then we're going to, in the afternoon, look at energy efficiency schools and universities. So we're going to take a look at just this particular customer segment and what are all the opportunities and what kind of benchmark data is out there available to benchmark this particular customer segment here. And then we're going to do something, it has a funny name here, energy efficiency benefits. And the premise is this, is that if you're going to justify energy efficiency upgrades, if you just look at the impact on your utility bill, you're really shortchanging yourself in terms of what financial and non-financial benefits there are from doing these upgrades. For instance, there's a number of financial benefits that go beyond the impact on the utility bill. For instance, if you upgrade your lighting and HVAC systems, you're going to impact employee productivity. You're going to make it more comfortable for your employees or even your customers in the facility. You might increase retail sales from a lighting upgrade, for instance. So we're going to talk about all that, and we'll quantify that. And then there are some non-financial benefits as well. For instance, do you want to achieve a green building certification, a LEED certification, or Energy Star? Upgrading your system is going to help you there. Now, things like that, they don't have a short-term financial payback typically at all, but in the long term, having a green facility is going to have financial impact in terms of the value of the building, et cetera. And so check that one out. Really, I'm going to show you that your non-financial, actual dollar-related benefits can be many times the dollar impacts on your bottom line that just savings on your utility bill will have. And then finally, the last one is, what's going on with commercial lighting? What's the best out there? And so we've attended some of the trade fairs, talked to all the vendors, looked at award-winning products. We've assembled all this together for you, and so we're going to review all that. You will be amazed at the innovations in lighting that's been achievable by the advent of light-emitting diode LED technology. So you don't want to miss this one. A lot of fantastic new products. Lighting's becoming connected, individually addressable. The control capability is amazingly increased, and it also affects things like our circadian rhythm of our life as we work in enclosed buildings, et cetera. We're going to cover all that in that webinar on December 16th. So let me look at the questions here. We have just a few minutes left here. And I see a question about when I talked about on slide, I think it was 14. Let me go to that here. How to convert EAR and COP to this full load value. And the equations are basically full load value equals 3.516 over COP. And so 3.5 over 3.5 is about 1 kilowatt per ton. And full load value equals about 12 over EAR. So again, that's why there's a 12 here. Over 12 would be 1 kilowatt per ton. 20 EAR over 12, I'm sorry, 12 divided by 20 EAR is about 0.6 kilowatt per ton. So those are the two formulas that we use to achieve our calculation of the kilowatt per ton, which is very useful when you know what your tons are and then you want to calculate, knowing the running hours, what kind of energy consumption your HVAC equipment is consuming in a ballpark. So let's see if there's anything else out here. Question-wise, I don't see anything else. So we've come to the end of our time, so I'm going to go ahead and turn it back over to Chris for some closing comments. Thank you for your participation today.
Thank you, Mike. I would like to thank you all for attending our webinar today. As a reminder, the presentation materials and the playback link to the recording of today's webinar will be emailed to you sometime within the next couple of days. If you have any additional questions or feedback, please do not hesitate to contact us. Thank you again for attending, and have a great day, everyone.